Okay, and once again, we're back to another JNation 2021 online session. So we only have like 3 sessions to go. So it's been a long day, almost in the end, but we still have some more content to you. I hope that you're enjoying the day so far, and I'm happy to have with me my good friend Andres. Hey, Andres, how's it going?
Hey Roberto, how's it going? How's everybody?
Yeah, I mean, really happy to have you here. Unfortunately, I've been saying to everyone, especially because I guess I mean this is not on purpose, but pretty much all people that end up on this room was people that I knew. So,
Hmm.
but I was mentioning that yeah, I mean we that we don't see each other in person for a long time, and even like Reza was here like in the previous session, and I remember that we last met at Atlanta, and I think we also met at Atlanta like in DevNext, which was like the last physical conference that I attended, and I guess it was the last physical conference that pretty much everyone attended from our community.
Oh yeah, that's pretty much it. Yes.
Yeah. So we hope that we can do this physically in Portugal next year. Let's see. So, I mean, you're actually going to talk about a subject that's really dear to me, especially because I'm advocating with Maven for so long as well. So I hope that I can learn a couple of things from you as well. So please let us know what you would like to learn about Maven so far.
Okay, great. So let me share the screen and turn on the slides, and let's see how it goes. Click. Oh, where is this button? Just move it away. There we go. Great. So for my name is Andres Almiray. This is the boarding slide. I love open source, and I work for Oracle, and I work for the database group, and we do open source. Surprise, surprise. Yes, that can happen. So if this is something that interests you, please talk to me because I really, really love to talk about open source. But today, what we're going to talk about is the Maven build tool. Now, we have to go through a little bit of history to see how we arrived to Maven. So as you know, pretty much 26 years ago, Java came out, and the designers of Java decided explicitly to choose a syntax that was very close to C and C++, because at the time that was a dominant language, and that allowed developers to jump from C and C++ into the Java platform because it was so easy to recognize patterns. Because of that reason, there were no Java-specific build tools at the time. We would have to use Make. So the promise of Java is that you compile one platform and you're able to run the code unmodified, the compiled code, in any other platform. Now, to do that, you need a build tool. And you need a build tool that is able to run in different platforms. So we didn't have that with Make. Make kind of is a little bit portable, but not exactly. So we needed something that was born inside the Java ecosystem to be able to build Java projects. And the answer came as the form of Apache End. This was one of the first build tools for Java. And because of the very nature when this occurred, there's a lot of XML involved because, hey, if it's XML, it's enterprise ready. And the advantage of End is clear. It's kind of like a Make that you can define whatever you want. And that is also part of the problem. You can define whatever you want. So every build is personalized, is customized to a particular project. There were not really much patterns or conventions that you could follow. Some time passed, and a group of developers from Apache also said, well, what if we were able to build a build tool that adds these missing features from End, plus a few other lessons learned from other spaces. And that's how Apache Maven came to be. Maven 1 was very close to End. There was, if you think that right now you have to build a lot of XML, you have no clue what you had to do with Maven 1. So Maven 2 and Maven 3 are much, much better in that regard. And it gave us plugins and conventions and dependency resolution and so many other different features that there was a big explosion of the amount of projects that you can build in the Java space thanks to Maven. But there were a few things that some people thought, well, maybe it's not working as they should. Maybe it's still too strict in certain cases. There are some other features or capabilities that are not provided by Maven at the time, or could not be provided by the design. So another group of developers, this about in 2007, decided to create a build tool called Gradle. Now, this is the time where I jump into the Gradle build system. One reason, because it's written, or the DSL that you use is Groovy based instead of XML. So I jumped because I hated XML. And because I could do something similar to what you could do with AND, but instead of using XML again, you will do using it with Groovy. Now, because I jumped so early, I completely missed the fact that Maven 3 was released in 2010. And there were so many features added to Maven since that release that I completely missed. I spent so much time in Gradle world that at some point I decided to come back to Maven and see what were those features that I might have been missing, and to draw a parallel between what I can do today with Gradle that I like, and what if I were able to do something like that with Maven. So one of the first things, you may be aware of some of these features, and please feel free to ask questions at any time and stop me with any questions. So one of the first features is that you can override project properties. As a matter of fact, you can define project properties in various ways. You may define a properties block in the POM XML. It may be your POM, or it may be coming from a parent POM. So we have hierarchies of POMs. That's something that Maven has that Gradle lacks. You can also define properties in plugins. And as a matter of fact, every parameter that is defined by a plugin or a module in this case, if every parameter has an additional annotation value called property and a value with that one, then that field will be exposed as a property. Now, it doesn't matter if you define explicitly the property on the POM file, or if it's defined by the plugin, you can still override values for these things if you jump into the command line. Now, let me show you a quick example of that. So here I have a simple project. It's called, well, no, this is just a simple POM file. So I'm going to do a clean right now so that there is no compiled classes, right? So what I'm going to do right now, let's see, which version of Java I have. I believe I have version Java 8, great. And I believe I may not have the latest version of Maven. Let's see, latest version is 3.8.1. I have the previous version, should have upgraded, but that's fine so for now. Okay, so this is what I'm going to do. I have a simple project, gap coordinates, and a single dependency, and a source file. It looks like this. It's a simple hello world that prints out a value. So what I'm going to do is compile this code. How do I do this? There are many ways. I can just simply do compile, or I can do verify, but because I'm using my own custom tool that knows how to invoke the Maven wrapper or Maven called GOM, I can just simply do build, and this will do the right thing for me, which is pretty much invoke verify. Now with this, I have the target directory. That's where my classes are. Perfect. Now, remember that I said I have Java 8, right? Okay, so I would expect that if I inspect the code, the generated code, which is in classes come acme, and let's grep the major version. Oops, Java P minus B, that's the wrong one. There we go. Major version 49. Does anybody take a guess which number maps? Which Java release is this one? That's Java 5. The default version of Java that's coming all the way from the Maven Super POM is Java 5. Now, but I still have Java 8. So how do I make sure that I have my compiled code use the version of Java that I want? There are a couple of ways that I could define a block in the POM file saying this is the Maven compiler plugin and say the target and the source, or I can set it in the properties, or as I'm going to show right now, I can do it in the command line. I can say, I'm gonna delete for now the generated compile code. And I'm going to say the following. I'm going to define a property. By convention, it's called compiler target. This is a property exposed by the compiler plugin.
If you look at the documentation, you will see what all the different properties. And I'm going to say I want to compile with Java 1.8 and do a build again. This runs Maven, recompiles the code. And if I inspect the generated bytecode, I now got version 52. This is what I expected. This is Java 8. So the advantage of what we just did is that it doesn't matter if I define the property in the POM file or is part of coming from the plugin. I can redefine values as I deem necessary. This will come back in a moment. So the next thing is, and this is something that I really like about Maven, that is something that is missing in Gradle, is that you can invoke any plugin just by passing the gap coordinates, the goal, and any additional arguments that may be needed. You don't have to define the plugin in your POM file. You don't have to define it anywhere in your POM hierarchy. As long as you have access to the gap coordinates, as a matter of fact, sometimes the version could be omitted and it will always be the latest release for that particular plugin and define the goal. So this is what we have. So as you know, gap stands for group ID, artifact ID, and version. So if I wanted to invoke the echo plugin for inside any project, I just have to pass in the gap coordinates. If I omit 1.2.0 as a version, if I just take that out, then Maven will resolve the latest version of the plugin. And then pass it any additional parameters that I may have. In this case, the echo goal expects one parameter called echo message. And now because we know we can pass parameters on the command line, then this should work. So if I jump back into the terminal, I can show you that I have a command already prepared that looks like this. Invoke Maven with the gap coordinates of echo and defining a single message like this. So what I'm going to do is copy this and to say that this is live, the message will be, hello, JNation 2021. Maybe that's gonna work. Okay, so I now have to say that I want to run Maven, of course. Oops, yes. I suspected that using this character will be a problem. Okay, so here we go. Now invokes Maven. Notice that downloads the Echo Maven plugin and outputs what I wanted. Hello, JNation. Now let's do that again. And this time it did not download anything because it's already available in Maven local. The plugin and the jars, everything has been resolved. And I only get the behavior that I want. That's pretty cool. All right. We're 2 for 2. Next, we go into dependency resolution. This is perhaps one of the features that many people were asking for when they did the switch from Ant to Maven, because it is very tiresome and error prone to find a particular jar, put it into your source control, compile your code, and then when you see, oh, I need an update, so you need again to scour the network where you can find a particular jar, the specific version, and then replace the file. Now, some people, before we used to have dependency resolution, what they did is that they will get the jar file that has a version in the name, and then just take it out, rename that, and then stash it in their Git repository or CSV repository. And that wasn't really nice. So the advantage now is that we no longer have to put our jar files into source control. We just let the tool do the thing. But there are some corner cases. Now, we define dependencies inside the dependencies block in your POM file. When you do this, the dependencies that you see explicitly defined in your POM file, these are known as direct dependencies. But because these dependencies may also be projects that have been published with Maven, then also they have their POM files, which means they could also have additional dependencies. They can bring those additional dependencies to your project. So those second level or nth level dependencies are known as transitive dependencies. Now, the way that Maven resolves dependencies differs whether they are direct dependencies or transitive dependencies. In the case of a direct dependency, that is the one that you will see explicit in a POM file. The last one that is found will win. But in the case of transitive dependencies, the first one that is closest will win. And there are a few things that we have to say about how version numbers are resolved. Now, last year, I ran a quiz with 14 questions on Maven dependency resolution. I split this in 3 sections. The first section is just regular transitive and direct dependencies. Then in a single POM, then we add a parent POM, and then we add a BOM file, a bills of materials. Now the answers were all over the place. So I'm going to show you just 2 questions, and I will send you the link also where you can find everything and the analysis of these questions. So here we have a simple POM file with 2 direct dependencies that happen to have the same group and artifact ID, but different version number. So if I invoke the dependency column, the resolve goal of the dependency plugin, which version of Guava will be selected? Will I get the first one, 27? Will I get the second one, 28? Or would I get a build error? Because clearly, who in their sane mind is going to define twice or even 3 or more times the same dependency, right? This is clearly an error. Well, when we resolve dependencies, this is what happens. Maven says, yeah, I detected a problem. You have duplicate versions, yeah, but I'm going to allow it. It's just a warning. And by the way, the last dependency is the one that wins. Again, direct dependency. Now let's turn into transitive dependencies. This is the first question of the quiz. We have 2 direct dependencies, use and truth. Both of them have a direct dependency on Guava. From my point of view, Guava is transitive. Both of them have 1 hop, it's just 1 hop away to find Guava, so they are at the same distance. Use depends on version 27 of Guava. And no, that will be 25. And truth depends on version 27. So which version is going to be selected? Is it going to be 25 coming from juice? Is it going to be 27 coming from truth? Or again, this might be a build error. Well, it's not build error. And turns out that the version of Guava that is going to be selected will be the first one that is found in the graph. And that version happens to be 25. Don't believe me? We can run this as a demo. I think I have this in transitive, the first version. So I have a POM file here where we have both juice and truth. So this is exactly the same on the slides, right? So I can invoke this dependency. Let's do so. And what do we get? We get, oh no, let's not resolve that one. I want 3. This is the one that will show me how they were actually resolved. And here we go. So we got juice and we got Guava 25. Okay, so now let's switch them over. And you can see in the POM file that now truth is first and juice is second. I invoke the same command as before. No any changes. And now look at what happens. The version of Guava that is resolved now is 27 because that's the one that is found first in the graph. All right. And this is something that tricks many people. And that's definitely something that tripped me over when I was coming back to Maven. That turns out that Maven is not aware of what semantic versioning is. This is what Robert Scholte said 1 year ago when it comes to resolving versions in Maven, is that, yeah, whatever, we don't look at the version, we just look at the position of the dependency in the graph. Now, that was fine years ago. Maybe it's the time now to change this, or maybe add a new strategy for Maven, some sort of configurable strategy that will enforce that you're actually using semantic version or any other strategy. Now, that thing is not done yet, but there are a few ways that we can tell Maven to select one version over other instead of just looking in the graph. One of the ways is how Robert says, is that we can use the enforcer rules. I'm going to show that in a moment. But another way is using the dependency management block. Now, the dependency management block can be in anywhere in your POM hierarchy. Right now, we're dealing with just a simple POM file. Notice that what I'm doing in this dependency management block is kind of like a redefining again the gap coordinates of a particular dependency, Guava version 28. And then I go again and define two direct dependencies that will have Guava as a transitive. What happens when Maven sees this block is that when it goes through the resolution of truth, it will see that it requires Guava. And if there is a dependency management block, then it will look at any matches from the group ID and the artifact ID, and there is such thing, then the version that is right there is going to be the selected one. This means that even though truth depends on Guava 25, and truth depends on Guava 27, and juice depends on Guava 25, the selected version will be Guava 28. And I think I have an example of that. Here we go. Let's look at the POM file. So here's the dependency manager block. Now have version 29 because there's an update. I think that the latest version is 31. I remember truth depends on Guava 27 and juice on version 25. So I run the dependency tree command again, just like that. And notice what happens. The selected version of Guava is version 29. So we have effectively overridden the default version coming from the transitives and saying, whenever you encounter Guava, anywhere in the graph, it doesn't matter if it's direct, it doesn't matter if it's at as many hubs as you have it in the graph, as long as it's encountered and there is a match with the dependency management block says, then that particular version is going to be selected. So Robert said that the other thing that we could do is use the enforcer rules. There is a plugin called the enforcer plugin, which I kind of like this phrase, the loving iron fist of Maven. Because one thing is true. Once you configure the enforcer plugin and a few of its rules, I guarantee you your build is going to break. And that is a good thing, because that means that right now your build is probably having some issues, but we have not uncovered those issues. And what the Maven Enforcer does with its rules is to bring those issues to the surface. Now, you may decide if those issues that have been reported by Enforcer need to be fixed immediately or in some other way, or these may be some false positives, depending, again, on your use case. There may be times that even Enforcer is telling you, you should not be doing this. There may be no other way to do what you must accomplish. So I also asked a question last year, who uses the Maven Enforcer plugin? And it turns out that, well, it's a very unscientific Twitter poll. And well, not that many people apply the Enforcer. Those that do know what the Enforcer plugin is like, meh. Then you have a lot of people that said, what is the Enforcer plugin? And there's just 10% of people that say, I don't use Maven at all. And it could be any other build tool. What surprised me is that the percentage of respondents are like, yeah, I do some Enforcers. And someone's like, I don't even have a clue, or yeah, I don't think that this is necessary. So some of the answers on the quiz. Turns out we had around 509 people answering the questions, and only 7 of those answered the 14 questions correctly. I was not one of them. These are the different sections. The answers based on, again, the first section is just a simple POM file. The second section is a parent POM file. And the third section is the BOM. You can see that the first section is like, yeah, the answers are okay. I mean, people know how to work around with a simple POM. The moment that you start to play around with the hierarchies, that things start to get a little bit less known. And once you add a BOM file, it's like, poof, okay, information overload, I don't know what it is. This tells me that not that many people know what the BOM file is and how it can work and what it can do for you. And finally, it turns out that none of the questions on this questionnaire could be answered with build error. Every single question worked correctly. And it's surprising that for the first question, remember when we had 2 duplicate direct dependencies, 35% of the people thought that having 2 definitions of the same dependency with different versions should be an error, but it's not. I already showed it's a warning. You can turn this into an error if you configure an enforcer rule that bans any duplicate dependencies. And if you're asking that maybe people thought this is an error because the IDE tells them it's an error, it does not. Eclipse doesn't show you a thing. VS Code doesn't show you an error. NetBeans has a marking on when you look at the POM file, it says this is duplicate. And IntelliJ also shows you a mark in the POM file that this is duplicate, but does not flag it. None of them flag it as an error. If you ever had any troubles with resolving class paths in Maven, what is known as the class path dependency help, well, I would certainly recommend you to have a look at this session from Robert Scholte again. He is the Apache Maven PMC chair, so he's the one that's overseeing the project, and there's a lot of volunteers working on the project like himself. And he's a Java champion, and there's another Java champion, Ray Sang. Both of them are very good friends of ours. And the link here that you see on the screen has a link to the video and to the slides and to every other content that is related. So one of the things that we saw up to right now is covered on this video, but there are a few other things that can happen with dependency help, and that this is definitely really high recommended for you to have a look at. Okay.
So actually, sorry to interrupt. So actually, both Robert and Ray gave the same presentation in JNation last year. So you should probably replace that link with the one linking to our own presentation. Just joking.
Yeah, no, I should have done my homework.
No worries. But I mean, probably people that already seen, like, if they were with us last year, maybe you remember Robert and Ray's session, or if not, you can just go to our YouTube and you can find it there, and then the sessions from last year.
Definitely. Right, thank you, Roberto. So the next thing is something that Robert has been saying for years, but I kind of like turned it into my own flag. You might have seen the memes happening from last year. Don't do Maven clean install. And yes, I know I did Maven clean twice already in this session. We'll see about that. So what is the problem with Maven clean install? Well, if you are into the Maven Club, as you know, the first rule of the Maven Club is you do not invoke a Maven clean install. Don't. The second rule is definitely you do not invoke a Maven clean install. The third rule is that you better be using Maven Verify. And if this is a very dark reference for you, let me give you some rainbows. Use Maven Verify. Now, so what's going on here? Now, remember about Maven 2 and Maven 3, and Maven 3 came out in 2010. So in the time frame of Maven 2, which came out around 2003, it's between 2002 and 2003, so it's been a long time. So when that was the case, whenever we built something, the plugins and the core of Maven did not support increment and compilation. So if you switch branches, or if you created new artifacts depending on certain plugins and you wanted to have another go at generating everything, you certainly did not want to have any intermediate results that may pollute or corrupt your artifacts. So what would you do? You will do a clean, and then another build or install or package, whatever it was necessary. So that's why if you look at on the network and look at every README that's out there, pretty much everybody tells you, clone this project, and the next thing you do is Maven clean install. No. Why? First, if you just clone the project, why would you do a clean? There's no point. There's nothing you need to be cleaned. You're just wasting time just running clean. And secondly, what do you need to do install? If I just want to test out the project, you just run the tests. If the project requires resolving dependencies from a local repository, then you might need to do install. But if the only thing that you need to do is create a jar or just run the test, just do test, do package, or do verify. If you look at the default lifecycle of Maven, you see there are different phases. So there is the initialization phase, and there's a validation phase. And then at some point there is compile, and then goes test and package, verify, and install. That's right. Install comes after verify, and verify comes after package. So if you call verify, then everything that is needed to prepare the resources and compile code and package and test will happen. What does not happen with verify is to push artifacts to a local repository. That is the job of install. So if you do not need to push to a local repository, stay with verify. What will happen now when you do this? Supposedly, the incremental compilation will kick in whenever you keep just doing verify, 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 and never clean, and your builds should be faster. There will be cases, though, where you need to invoke clean. We know for a fact that it's not the WAR, is the ER plugin. If anybody's still packaging applications using ERs with EGBs, clean does not work. If you are using any other plugin for which you must invoke clean, please let the Maven community know. Send a message to the main list telling them about your use case, because that is definitely a bug. And that's something that should be fixed, and the Maven community should be able to rally their resources so that we can fix this and have a much better experience with incremental compilation. Now, Robert has another great session, and sorry, Roberto, I believe this one is only available on DevOps, where he goes in great lengths explaining the history of what I just said and why clean install is not something that you should be using all the time, and that verify will be the preferred way. But I do recognize there are valid use cases where you must use clean and also where you must use install. But just invoking clean install all the way is, I have to say very bluntly and very honestly, that is a cargo code coming from Maven 2. Maven 3 has changed the game and makes things a little bit better in that regard. But because we cling to the past, as I did when I completely let go what Maven 3 is, and I'm just thinking what Maven 2 is, I completely missed that Maven 3 has made a lot of improvements. Here's another thing that I like from Gradle. You have a multi-project build, and you want to invoke just one goal or one task in a specific subproject. But if you want to do this with Maven, it's possible, but it's a little bit more verbose than you may think of. And for this, we use these two flags, -am and -pl. So when you run a multi-project build, this is known as a reactor. Now, the name reactor comes from, again, from Maven 2. Maven 2 was designed to build just one project. There was a plugin that was created called the Maven Reactor plugin that gave us multi-project support. And that project was added to Maven 3. And for that historical reason, we continue to call this reactor instead of just regular multi-project build. Now, the reactor will execute all goals for all projects. So when you say Maven compile at the root of your project, you know that the compile phase is going to be invoked for every project in your build. But if you want just a subset of your build, then you can pass in the -pl parameter, and this PL stands for project list. So you may pass one name or as many names as you want. But if you do this, you may find that some of these projects may fail if any of them have interdependencies from one another. In order to fix this, you pass in a second parameter, a second flag, which is called a -am, that stands for also make. So what also make does is, given the list of projects that you have given as an input, it will look at all the dependencies within the reactor and say, I also need to make these other dependencies. Otherwise, the small set of project lists that you gave me will not work. So let me show you a demo of that in action. Let's go into the terminal, and I have this other project called partial one. Okay, let's do a clean so that we start from a fresh start. And what we have here is a root project and 4 children. The root project.
Sorry, Andres. Before you move on, can you clarify the clean and ER? Is
Yes. So what happens is that the way that the packaging for ER happens, if you were to be switching within branches and you have any additional resources coming from one branch that should not be available from another, or there is some resource, intermediate resource that should not be packaged in the ER, then you definitely need to do clean. If you don't do this, then the final artifact that is created may contain outdated classes, outdated resources, or files that should not be part of the package. And again, this is a known bug in the ER plugin.
Wonderful.
Great. So we're back here. Here's our root build that says I'm packaging as a POM and have 4 sub-projects. Good. We look at the first project, and it has just gap coordinates inheriting from a parent, nothing special. Project 2 saying gap coordinates, and it has a dependency on project 1. Project 3, gap coordinates and has a dependency on project 2, which means it has a transit to dependency on project 1. And project 4, which is again just a regular project. Okay, so if I just want to build the project 4 like this, let's see what happens. Oh, I didn't say anything. What do I want to do? I just want to build it. And project 4, fine, it works. Why? Because it has no other dependencies. Let's see what happens when I do the same thing for 3, which remember depends on 2, which depends on 1. Let's do a build, and we have a failure. It says it could not resolve the jar file for project 2, because again, Maven resolves dependencies from repositories, for which you have 2 types, local repository and remote repository. But because we did not push project 2 into a repository, we got a failure. And then this is where people say, oh, I know how to fix this. I just call install, which will put project 2 and anything else in a local repository. And then I can compile project 2, right? But if I make changes to project 2 and I forget to do an install and expect those changes to be visible on project 3, then this is where the problem occurs, because I have outdated snapshot dependencies on a repository. Now, notice what happens when the only thing that I do here is add 1 flag, also make. That's the only thing that I do. There's nothing on my local repository. And now it works. And as a matter of fact, the reactor says, I'm going to build the root because you need it, because it's the parent of every other child. And I'm going to build project 1, 2, and 3. And you can see that it compiles the code and tries to run. There's no test cases for any of these projects. And then does the same thing for project 2, and then goes around for project 3. Yeah, it works, right? Okay, so I have another version of this thing, which is, let's do like this. Let's do a clean first, so that again, there's nothing. I have, again, 4 projects, but project 3 happens to be an executable project. Let's look at that. Yep. I should have done it with, hold on a second. I can do this. Here we go. So this has the Apache Maven plugin. And there is a class that can be executed, com acme main. All right. Actually, this one is the fix. If I'm not mistaken, partial 1 has the same thing. No. This one doesn't have field. So this is what I'm going to do. We're back into the project that is basic. And I want to do the following thing, which is GM. I'm going to say project 3. Oh, we know that if we want to build project 3, then it also has to be -em, right? Now I'm going to execute the Java plugin. Now exec plugin, I will have to pass in the gap coordinates for the plugin, right? But exec happens to be one of those well-known plugins that live under a specific group ID, which is the org module house group ID. There are also other plugins such as the compiler and Javadoc and jar that live under org Apache Maven plugins. So plugins that run into this particular group ID can be executed just by passing the short ID of the plugin. This is the reason why you could do this. This is the same reason why I could do dependency tree before, because this results to Maven dependency plugin into group ID org Maven Apache plugins into certain version that I did not need to specify. Okay. Another thing that I need to do for exec Java is specify the main class, but we know that we can do this by passing parameters on the command line, right? So this is what I showed this before. And the command line, the parameter should be com acme main. Okay, just to be for good measure, I'm going to compile the code just in case. Let it rip. Oops, we got a failure. Let's see what the failure says. Well, the reactor is the subset that we want. That's good. And then notice what happened. Exec Maven plugin is being invoked on the root project. Hold on a second. I wanted this to be invoked on project 3. Why is it being called on the root? Well, because if you remember, I mentioned that every single goal that you define in command line in your build is going to be invoked for every single project inside the reactor. So exec Java will be invoked for the build for project 1, project 2, and project 3. None of them, except project 3, can be effectively executed. So we clearly have a problem now. How can we run project 3 without doing an install? Well, there are ways to do this. So the workaround that exists right now, this is something that the Maven team is looking at. It's probably something that might be fixed for sure in Maven 5. Hopefully we can get it earlier in Maven 4, but there are no guarantees yet. So what you can do for now is define the exec Maven plugin explicitly on the parent and disable it by default. And make sure that every subproject inherits this dependency or this definition, so that when you invoke it, it will simply say, oh, yes, I have it, but it's ignored, it's skipped, so I will do nothing. And for those projects where you definitely want that execution, then you will enable it. You will see that in some cases, you need to define some dummy values. In this case, the exec main class. So now I can certainly move into partial number 2, but you can see now the root has 2 properties defined by the exec plugin, exec skip and exec main class. Main class could be anything. It's just gibberish. You need a value. You don't need a specific value. And we also said a skip through, which means that if you invoke exec by default, it will say, no, I'm not going to do it. And then in plugin management, we say, I'm going to apply that plugin. The coordinates is fine. Inherited is default, so this shouldn't be here, but I mean, it's there. And it's one thing to say, I want this configuration. This is the universal possibilities. And this is where I actually apply the plugin from the root. And the children will inherit this. So in effect, every project now in my build will have the exec Maven plugin applied to it. And then just the rest of the modules. If we look quickly at project 1, no changes. Project 2, no changes. Project 4, no changes. And project 3, this is the one that changes because I have already defined the plugin, well, might as well define the property right there in the POM file because I know this is what I want to do. And what else? I think you could define exec skip equals false here, but you could also do it this way. When you explicitly define again the plugin, notice that we don't have to define the version. Why? Because it's coming from the plugin management block that is defined in my parent. But I do have to say skip false. This means that now the plugin can be executed. So with this information, now I can say -am. Actually, let's look for that line of code that we have here. And we can remove this. Let's see what happens now. Notice that again, I'm only saying I want to run this on project 3. So we have a reactor and we got no failure. Perfect. And then let's inspect at the log. We see on the root file, there is the execution of Maven plugin, the exec Maven plugin, but it was skipped. Okay. Project 1 does compilation because it has sources, but exec was again skipped. Project 2 happens the same thing, compiles, but exec was again skipped. Again, this is the default configuration. And finally, for project 3, we got compilation and we got execution. This is what we want. So it's a little bit more verbose than what you can do with Gradle right now, but it's possible. Okay, we're almost there. The next thing is aggregating POMs, which is something that we kind of see already, but there is something that is very important to distinguish. Aggregating POM files are those that have a modules section, like the one that we see on our root build file here. But they do not have to be parent POMs. They typically are, because in parent POMs is where we define common behavior, common configuration that the children may inherit. And you can have a hierarchy of parent POMs. Even within your project, you can have multiple intermediate parents if you want to, as you go down into your project structure. But an aggregating POM does not have to be a parent, not necessarily. Also, the value of the module is not the project name, it's a project path. But because it's common custom to have project names, projects be adjacent to your root, or to be in a single, in a single directory, then we tend to equate project names to project paths. So here's what we have. Let's say we have this structure where there's the root file right there, POM XML, and we have two children, base and BOM. Our root could be something like this, says BOM and base. And if we were to inspect the contents of this POM file from base or this content, you won't see the parent. Why would I want to do something like this? Let me change it a little bit. Say that this project base is your project, and you have a dependency on Apache Commons Lang, which is quite natural. Or let's put Guava, because it's easy to pick on Guava. Guava is broken. We know this, but there's a particular version that you're depending on that has a problem. There's a bug, and you can fix it, but you want to test it first. Now, typically what you do is clone the code and then fix it, and then push it to a Maven's local or to some repository, switch into your project and consume it and see if the fix works. If it didn't, then you go back to your clone, try to fix the problem, and go back, and you do this iteratively. And you know that you're just pushing files into an active file repository. But what if Guava, or your dependency that is broken, and your project were to be in the same multi-build project? Then you could simply do Maven test, Maven compile test, Maven verify, and that will run Maven test, compile, and verify on every member of your whole project, right? Which includes your original project and the broken dependency. This is the reason why you would like to have aggregating POMs that are not parents, because your broken dependency may have its own parent, and you leave it at that, and your own project may have its own parent, and you also want to keep it separate. But by putting an aggregate on top of all of them, they become part of the same build. And finally, POM files. POM files look like this. They have a dependency management block where you define, again, the gap coordinates of your dependencies. The idea is that a BOM file should define only a dependency management block and gap coordinates. And if you publish to Maven Central, any other element that is needed for publication to Maven Central. but you should not put a build section or a plugin section or something else. Unfortunately, there's no way to constrain this because a BOM file is a valid POM file as well. Now, once you do this, you typically say, I have a bunch of dependencies that go together, and you put them in the dependency management block. Then your consumer will use your BOM file like this. You define a dependency management block again, put in the gap coordinates of the BOM, and two additional properties that are very important. One, the scope has to be import. And second, the type of the dependency must be POM, because if it's not, then Maven will try to resolve a jar file. And the packaging of a BOM file is typically POM. If you don't do this, you don't just add these two properties, then you're going to have a bad problem. And once we have do this, then we can, just like if the dependency is coming from the BOM, were defined explicitly on your POM file, it turns out to be just like any other regular dependency management block and just works exactly the same. And I believe that this is pretty much what I have today. And so what I'm going to say is that I like Gradle, but I have another look at Maven, and I have found features that I didn't think existed. And I wish I knew before, because maybe I would have not spent so much time with Gradle. I have a few resources for you. There are some blog posts that tell you more about Maven. And if you're still stuck or you are using Gradle and you want some of the features that you find in Maven, well, the last link will tell you there's a set of plugins that gives you Maven-like capabilities on top of Gradle.
Wonderful. Thank you, Andres, for this wonderful presentation. We're pretty much really out of time, so we have to cut up and go for a break. So thank you so much for joining today, and hope we can see each other again soon.
Yeah, thank you. Sorry, I think I was very excited about the topic.
I know.
So just feel free to reach me anytime online. There's my Twitter handle, there's my blog. So you know I'm the Maven clean guy. So yeah, send your questions to me. I'm very, very happy to be here with you. Roberto, thank you very much for the invitation.
Thank you. So we're gonna go for a break and see each other in a couple of minutes. Thank you.
Bye-bye, everybody.